Hello everyone, I am Giti Makachari and I am here to share with you my learning on ticket programming, and I call this as ticket programming for beginners. And for that I will be sharing and discussing with you the ticket script which I had written for automation of static timing analysis for a RISC-V CPU design. So let us now discuss about the problem statement. As I had mentioned earlier, the ticket programming, I'll be explaining it based upon the script which I had written. So it is very important for you all to actually understand the problem statement which I had defined, and what are the different steps which I need to carry on to in order to solve those problem, and what is the approach which I had taken, and then to solve the problem. Okay, and this actually I wanted to give a brief overview of all these before moving on to the coding part. So now, as you can see, the problem statement which I defined is to automate the static timing analysis for RISC-V CPU design synthesized using OpenLane with ticker scripts and generate a report table that shows the result. Okay, so this is my full problem statement, and I had divided the problem statement into two parts. First part is the optimize or automate the STA script using OpenSTA. OpenSTA is the tool which I had used for static timing analysis, and next is the generation of report table. Okay, so as you can see, for automating the STA script using OpenSTA, the timing libraries which I had used, it is the HD timing libraries of Skywater 130 PDK. Also, as you have seen that I had synthesized the RISC-V CPU design based on OpenLane. So I have the netlist for the different stages, say post synthesis, post CTS, post layout stages, and I'll be doing the analysis for all these three stages. Okay, and so as I'm using the I'll be using 15 timing libraries of Skywater 130 PDK. I'll be showing that later. Okay, and also as there are three different stages, so there will be a number of reports which will be generated. So I wanted to save all these reports in a particular order in their respective folders. Okay, and also while saving these reports, I wanted that the reports should follow a particular naming convention, and this is what I had decided. So it has to be, first has to be the PVT corner, then the design flow stage, and the report type. And out here I have shown one example. This is the PVT corner, this is the TT025C 1V80 PVT corner, then the post synthesis stage, and then the report type is the min-max report. We have three different reports. One will be the min-max, one will be the WNS, and another will be the TNS. And also the design flow stage, three types of design flow stage as I mentioned. It is the post synthesis, post layout, and post CTS stage. Okay, and there are 15 timing libraries, so you can understand that there will be a number of reports which will be generated. So this will be my first part. Okay, now after the generation of the reports, I wanted to generate a report table which actually shows the result based upon the reports which we had generated. So for that, what I had decided, we had decided that we will be generating an HTML table format. Okay, and then obviously we have to read the report from the respective folders, and whatever values which we want to extract, I'll be showing that. I'll be showing an snippet of the table which I had already extracted. Okay, and then extract the required values, and then from the report and append into the table. And then obviously, like, the table will be generated for all the stages. That is, there will be one table for post synthesis stage, one table for post CTS stage, and one table for the post layout stage. Okay, so now let's move ahead with the problem statement. So this I have given a pictorial view of what are the input, what you can expect as the input and the output. Okay, for STA timing analysis using OpenSTA, as you can see, the input files are the timing libraries, which are the Skywater HD 15 timing libraries I have been using. These are the .lib files, then the Verilog files from the OpenLane flow. Okay, and then the others obviously will need the constraint file which is in the form of .sdc, and the spec file. And this file, whenever we require, which on the post layout stage we will be using the spec file. Okay, and these will be my input files, and these input files will be providing to OpenSTA tool via via the commands which I use for OpenSTA, and both based upon those commands the analysis will be done, and then our output files will be these three. As I had mentioned earlier, there will be the min-max report, which is nothing but the whole and the setup report, then the worst negative slack report and total negative slack report, and these reports there will be total of 9 reports, if you can say. One for the post synthesis stage, 3, another for the post CTS, same 3, and another for the post layout stage. Okay, now this is for the static timing analysis using OpenSTA. Now next is for the generation of report. As you can see, now these are the reports. Now after generation of the reports, this will be the input files. Okay, and for the generation of a report, obviously I'll be using only these reports. Based upon the reports, I'll be extracting certain values, and then this is a snippet, as I mentioned earlier, that this is a snippet which I had generated while doing the coding part. Okay, and as you can see, this is only for the post synthesis stage, as it is an HTML table, so you can see it has open in a browser. Okay, so this is the static timing analysis post synthesis stage, and these are the different values which I need to extract. Firstly, as you can see, the PVT corner, the start end point of whole, start end point of setup, whole setup, whole slack, setup slack, WNS, FEP setup, and TNS. Now I will not be showing you all the report. I will not enter into the report and show you all, because I had done this in the coding part. Okay, so there I had explained about the different values. Okay, so I will not move ahead more to that. I just wanted to show you all what you can expect, what you will be expecting finally. Okay, so let's now discuss about the approach which I had taken to solve my problem. Actually, initially when I was working with static timing analysis for the RISC-V CPU design, I had done the same thing for the 15 timing libraries, and for all the Verilog files I had done the static timing analysis. But in that time, what happened, when the first time I had done that, I had used single libraries, one library at a time, one Verilog at a file at a time, run the whole thing for those, and then generate the report. Then from the report I had copy pasted the values into the table, and then generated the table, and then I had moved on to the next library files and next Verilog file, and so on and so forth. And it was such a time consuming task that later I became frustrated, and that is the reason why this problem statement had come into picture actually. Okay, so now it was a bit diversion from what actually I wanted to say, but anyways, let's now move back to the approach which I had taken. And the approach which I had taken is a divide and conquer approach. As you can see, the overall problem, which was that the static timing analysis automation for of the static timing analysis of a RISC-V CPU design, and then the generation of a report table based upon the reports which I generated. I had divided that into 2 parts. Okay, and after that also what I had done the static timing analysis first for a single Verilog file, and then I had moved ahead to the for the other 2 Verilog files. Okay, so let's discuss what I had done. So initially, as I had said, I'll be using the different timing libraries, and I had used the 15 timing libraries available with SkyWater 130 PDK. So for that, what I have to do, I have to assign those libraries to a variable, and then use a loop within those libraries, and then move ahead with whatever I wanted to do. Okay, so the first thing after doing that, the next thing which I had focused on the naming convention. Okay, and for the naming convention, as you can see that I had used the libraries itself. Okay, for the naming convention. Okay, because as you have seen in my naming convention, the first thing was the PVT corner, then the design flow stage, and then the report type. As I move ahead, you will be seeing that I had initially focused only on the PVT corner. Okay, so now for that, why I had used the libraries, so let me just once show you all the timing libraries. before moving ahead. Okay, so let's go there. So here are my timing libraries. As you can see, these are the timing libraries .lib files, and the first thing which I wanted was the PVT corner, and those PVT corners are available in this timing libraries. I mean the name of this timing libraries. I call this the name as the root name and this as the extension. Okay, like that is what it is called as. Okay, so as you can see here, these are the PVT corners. So I was thinking how I can work with this timing libraries to get this PVT corners, and how I had done that we will be discussing during the coding part. Okay, so this is the the thing for the PVT corner. I had worked with this timing libraries, and for other values also I had worked with the extension part initially in the, I can say that is the first stage of my naming convention. And as I will be moving ahead with the coding part, you will be seeing then apart from the timing libraries I had also used the Verilog files, okay, for the naming convention. That will be in the next stage, I can say. Okay, so let's let's go back to the presentation. Okay, so out here as you can see what I have done, as I said, I'll be assigning these variables to assign the libraries to a variable, and then we'll be looping among the libraries. And then for the naming convention I had worked with the libraries, okay, and then I had created directory. I'm not going into the each step into the details, just an overview I'm giving. Okay, so next, after doing the naming convention, the next thing is these are within inside the loop. Okay, this also and this also. Okay, so here after that what I have done, okay, now obviously the thing is that I have to run the OpenSTA tool, and for that there are certain commands which we need to write, and there are certain, these are the different commands which we the basic commands which is used in OpenSTA. These are the read liberty, read verilog, link design, read SDC, read spef, and the spef part whenever we require that time and we use. Okay, and as you see, the input for all these are the path along with the .lib files, the .v files, the module name, .std, the spef files. Now for this we have to give the path where these are present, and in case of library, as we are looping among the libraries, this read liberty will be based upon the variable which we have used for the looping. Okay, and for verilog file, as you have seen, this is for the single verilog file. So initially I had directly given the path wherever my verilog file was present. Okay, then next, the link design, the module name, whatever the module name is in the Verilog file, that we have to link with the Liberty file to actually move ahead with the analysis that we have done. And for the SDC also, the part wherever my SDC is saved, as you had I don't know whether you had noticed or not, there in the Verilog file there was the spef file and the SDC file also. Okay, and so those part I had to about the path and all these I will be discussing as we move into the coding part. Okay, those are the input files, I mean the part, the region where it is present, these files. Okay, now these are the commands, and then we have to run the STA tools, and then the reports will be generated. So here I have given an example of the post synthesis stage. In the post synthesis stage I will have the min-max report, WNS and TNS report, and I had actually created the folder also in this way. Post synthesis, outside there will be another folder, output dir, I think so, there, and then inside there will be the post synthesis folder, the post layouts folder, and the post CTS folder. And inside those post synthesis, post layout, and post CTS, there will be the min-max, WNS, and TNS folders. Let me just show you the folder. Okay, so here this is my output directory. Okay, so here this I had created through the in the script itself. Okay, you'll be seeing how I had done that. So here then this is the post CTS, post layout, and post synthesis. So let's just check the post synthesis stage. So as I have sent the WNS, TNS, and WNS min-max reports, and here these are the reports. Like as you can see, this was my my naming convention, which was the PVT corner, the design flow stage, and then the report. Okay, same holds. I will not go into inside the reports because I had done that in the coding part. And here post synthesis, TNS report, and so on. And this is the post synthesis WNS report. Let me just show one CTS also. excuse me, this is the post CTS stage. Same will be having min-max, CNS, WNS, and then here as you can see the design flow. The difference in this case is the design flow stage. This is the post CTS min-max report, then post CTS TNS report, post CTS WNS report. Okay, and similarly if you go to put a post layout stage, you will also get the post layout min-max, WNS, CNS, and here also the design flow. The difference is only in the design flow stage and so on. Okay, so let's move back. Okay, so this is what. Okay, now after I had generated the report, as I had not moved into the different Verilog file. I had carried on until I was able to generate a table. So as you can see here, this in this case, for the generation of the result table, the first thing was to create the table format. In the sense, the headings, whatever I had wanted, this I had to create, and we had done. I'll be showing how we had done that. So as you can see, this is only for the post synthesis stage. Here the PVT corner, start and point, and start and point of whole setup, whole slack, setup slack, WNS, FAP, TNS. These this format I had to make, and after that I had to work on the report files in order to get the values. Okay, as you can see, for the PVT corner, for these two I had worked with the naming convention view only. Okay, that means with the library files name only to get these. That I had done only actually for that, as you have seen, sorry, not the timing libraries, but the reports will be my my input. Okay, like for this case, now as I think you had noticed, the first thing was the PVT corner. So I had generated this PVT corner, and I had done it only once. I think I had used the min-max report to generate I had used the min-max report to generate this PVT corners, and these values I had extracted from the reports, okay, which I had discussed during the coding part. I'll not be showing now. Okay, so for that, as you can see, after generation the min-max report, these, as I had said, the output of this will be the input for this. So here we had created a format, and then we will be opening, and we have to read the reports, and then we have to pass here I had shown work with the report file name to obtain the required PVT corner only once, right? And then we have to read into the file line by line, and based upon the patterns, say for example start or end point whole, start or end point setup, or whole setup and setups, like based upon the pattern which we have given, we will extract those pattern, and then we will assign them into the variable, and then finally we will use those variable to write into the particular column. Okay, so this is what we had done. Now next okay, this is for the each Verilog file. Okay, so here in this case, as you can see, I had shown everything. I mean, from the static timing analysis to the generation of the table. In this case, I'll not be showing the generation of the table because it is the same thing out here. In this case also everything is the same, except one thing is that I had used all the Verilog files. In this case also I had assigned the Verilog files to a variable, and then access those Verilog file one at a time. As you'll be seeing, like the variables, whenever we assign some files into the variables, those come in the form of a list. Okay, and the list it starts from the 0th element, and based upon the tickle command. Okay, now I will not be discussing about the command now, we'll be doing that later. Based upon the command, we can access whichever list we want. Suppose in a list, as in case of timing library, there are 15 timing libraries, so the list will start from 0th element, so it will be from 0 to 14 element, and based upon command in tickle, we can extract any of the lists. So for example, if you want the fourth list to be extracted, so we can do that using an tickle command, and then we'll not move into that, we'll move on into the we'll do that into the coding part. Okay, so that we will be doing. Like in this case, initially I had done it was only for single Verilog file. Later on, as we will move ahead, I have done it for the different Verilog file at a time only, means in a single script only. So after that, now as you can see, initially I had used only the timing libraries for my naming convention, but later as we move ahead, you'll be seeing I had also used the Verilog files for the same. Okay, and others are same thing, and then we move on ahead with the table, and in case of post CTS stage also you'll be seeing it's the same thing. Post synthesis, oh yeah, for the reports, so I'll be generating it at a time only for post synthesis, post CTS, and post layout time stage. But in case of the report generation, I mean table report generation, everything we have to move out from the post synthesis folder, and then we have to move into the post layout system folder or post CTS folder, and that what how we had done, I'll be discussing it later. So I hope you had understand the approach that I had taken. As I said, divide and conquer. Initially what I had done, let me just go back to it. What I had done, I had done it for the single Verilog file. In this case, I had used the library's name itself for the naming convention, and then I had loop among the libraries and use the different commands necessary for the running the OpenSTA analysis, then generated the report, and then the reports was an input for the next part, which was the generation of the results in the form of a report. Okay, and this is the first thing which I have done. Okay, and next was that I had used the same thing for I had done static time analysis for each Verilog file. In this case, the difference is that how did I the way I had accessed the Verilog file, and that for the naming convention I had used both the timing libraries as well as the Verilog file. Okay, so now let's see what we will learn. So I have given here the overview only, what you will learn, what you expect to learn during the TCL programming via the script which I had written. Okay, so obviously first thing you will be learning static timing analysis using OpenSTA. Apart from that, you will learn how to access the directory part of a file with required extension. So let me show here one thing. Say I had done this and okay, so as here in this case the timing libraries, you can see that apart from the .lib files, there are other two variables, I mean other two folders also. Now so you will be learning only to access the .lib files. Okay, then we can also learn how to arrange or sort it in order. Say I want to arrange it in the reports, you'll be seeing that later in an ascending order, alphabetical order, that you will be learning. Then only the file name from a given part. For example, as you can see, if we move on to this part, when we talk about this part, okay, let me just show the part. So this is the entire part. Okay, and from there you will you'll be choosing the .lib part. Now you will also learn how to access only the file name from the entire part. Okay, the final part. Okay, that you will be learning, and then you will also learn to separate the root name and the extension. It had already shown the name of the file. This was the root name. You'll be able to separate this, segregate the root name into different variable and the extension to the separate variable. Also, as you'll learn how to work with file names, because as I had mentioned earlier, I had used the library name and the Verilog file name itself to obtain what the required naming convention which I wanted. Also, you'll be learning the splitting of file name. As you had seen in the library file name, there are other different stuffs also which we did not want apart from the PDT corner. So you'll be learning how to split those. Also splitting, also you'll be learning, I think, two ways. There's another way also which my mentor had done. I'll be showing that later, maybe in future videos. Okay, after that you'll be learning to retrieve a particular element from a list. As I mentioned earlier, like in case of timing libraries, you'll be using a particular command and you'll be able to access suppose the third element that you'll be learning. Then manipulation of strings, how to replace any string with some other string, then change the first letter of the string to capital letter. Okay, and then you'll also learn how to change the entire string to capital letters. And then you'll also learn, as I'll be saving the outputs in particular folder, you'll also learn how to direct the output from the OpenSTA and to separate files and save them, okay, in the respective folders. Apart from then, you will also learn input output file handling, because obviously you have to read the report, you have to write into the report, so all those comes into the input output file handling category. So you will be learning all those also. And then in this case, as I had said, we will be using STA HTML, you will be generating HTML folder, and for that actually we had somehow written the HTML. We have this generation of a table is also a very simple way where we had used the HTML commands for generating those. Then how we had used the ticker script to write those commands into an HTML file, that you'll be learning. Now also you will be learning the importance of the input output file handling command. This puts command played a very major role while generation of the table, and you will see different very simple puts. It's a very simple command, but the way you write, the way you provide the input for the puts, that also it influences the output. You'll see that also. Okay, then you will also learn working how with the regular expression. Like as I said, we have to extract certain patterns, so you'll be learning the regular expression, how to match those patterns. So you'll be learning. Then how you parse line by line to check for the patterns, that also you'll be learning. Then associative array for keeping a track of similar pattern and accesses whenever required, that's also you'll be learning. Apart from that, you'll be also learning with working with different files in different folders. As I mentioned, that we have 3 different folders you have already seen: major folder, post synthesis, post layout, CTS. So you will also be learning how to move move out from one folder and move into the other folder, and then work with the reports of that will be learning. So for that you'll be learning as you have seen, for that you'll be learning actually the regular sub command, which is really a very nice command. It's very simple to move from one folder to another. Okay, as you have seen, shifting from one folder to the next in a single line code. Actually in TCL you can write multiple number of codes in a single line. So I had mentioned this line. Actually I somehow preferred writing a number of commands into the single line. So that's why I have written this. And apart from that, you'll also learn some other things which I had not mentioned here. So now let's get started. That means let's move ahead with the coding part. Okay, so let's move on to the scripting part. I will be using the Vim editor to write my scripts. You can use any text editor. Okay, now for that I have to first open the terminal, and for that I use the shortcut keys Ctrl+Alt+T, or you can directly open the terminal. Okay, now after that I have to move to the location where I want to save my scripts. For that I use the script cd command, and then simply type in the what do you call this, the path. Okay, or you can simply copy the path and then directly paste it out here. So let's do both of them. Okay, it's cd, my path is my space. Yeah, you can type few letters and press the tab key. It will automatically take the rest. Corner variation, and then it is STA OpenSTA resources is 5 ticker scripts. This you can do, or you can, as I said, you can directly copy the path. Okay, and for that you simply need to go to the path location and then simply use the shortcut key Ctrl+L, copy this, Ctrl+C, and then simply paste it. But we are already there in the path, but still let's just show cd and paste it. Okay, now as I had mentioned earlier, I am using the OpenSTA tools for my static timing analysis, and therefore there are certain commands which I have to execute for the analysis. Okay, now let us see what are the different commands which we'll be using in our script. Okay, now I have already opened that. So let's see, these are the different commands. If we have to read the liberty, the timing libraries, then we have to read the Verilog files, and then we have to link the design, which is basically the name or the module name of the given Verilog file. Okay, and then we have to obviously read the constraints, and then we have to read the spec file as and when required. Okay, these are the, we can say these are the input which are needed for the analysis, and these are the different commands: report checks, report TNS, and report WNS. These are the commands which we need to execute for generation of our reports. Okay, and there are several other commands and different ways of writing, not exactly writing the script of the analysis for OpenSTA. Okay, for that you just check the OpenSTA PDF. Okay, here I had already opened this. This is the OpenSTA PDF. Here we are already given the sample command file. Okay, and then there are others. You can check all these, and this documentation, it is available in the OpenSTA GitHub repository. You can easily get it from there. Okay, now let's move on. As I mentioned earlier, these are the commands. We can simply execute these commands and we can see the report. Okay, so I mean, we can see the reports, like the report. Okay, I'll be discussing about this later, but let's just see how what is exactly the output. Okay, now here, as I said, these are the input files, and I had taken only a single timing library, which is Sky 130FD SC HD TT 025CC 1v1 1.80.lib and synthesis Verilog files, and the Verilog files are actually obtained from the open lane flow, and I won't be moving into that direction, as I'll be basically focusing on the tickle scripting part. Okay, now okay, we'll do that later. So let's just see what will be the resulting output or the reports which will be generated, okay, out of these commands. So here we are for execution of the STA. We simply need to use the command STA, and then we have to give our script, okay, which is rvmid.tickle. Yeah, this is the report, min-max report. We'll be discussing this about this later. However, I have already discussed about this in one of my webinar. Okay, so maybe I'll upload it in YouTube. You can check it out there. Okay, now here, this is the report checks. From the report checks we got this, and this is the report TNS and WNS. We'll be discussing little about these later, okay, but we won't be going into the detail of all these. Control C. So this is how the output will be. Okay, this is the result, the output which we have seen, that is only for a single library file. Now, as I had mentioned earlier, I will be using the timing libraries which are available with SkyWater 130 HD timing libraries. Okay, these are the one, here I had opened these are the timing libraries which I will be using, and so there will be, obviously I'll be using a total of 15 timing libraries, so there will be total of 15 min-max reports, 15 TNS, 15 WNS reports which will be generated, and I want those to be saved in particular folders, as I had mentioned earlier. Here to the output, it is shown in the terminal itself, but later as we move on, we'll see that I'll be saving my reports in a report file and in separate folders. So okay, so that it will be easy for us to analyze it later, and after that I'll be generating a table from those analysis, but we'll be discussing about that later. Okay.